Okay, sometimes we have to just come up with a way to solve a trinomial like this. So let's say we've got something like this, x plus 3 all squared equals 11. Well, the way to solve this is we can just take the square root of both sides. That gets rid of the squared. So if I do this, what I end up with is x plus 3 equals plus or minus root 11. You remember earlier we had something like this. We had x squared equals 9, and when we square rooted both sides we got x equals plus or minus root 9 and x equals plus or minus 3. So just reminding, when we're square rooting we get a positive and a negative answer in this case. Okay, so what we get now is we get minus 3 from both sides, so we get x equals plus or minus root 11 minus 3. Okay. Let's have a look at the next one. Same idea. We square root both sides, so we get y minus 2 equals plus or minus root 7. So we get y equals plus or minus root 7 plus 2. Now the convention is to lead with the positive integer, so 2 plus or minus root 7. And that's in exact form. We're done. So let's have a look at this next type that I've got here. In this case, it's asking me to solve this quadratic equation by completing the square. Now the way to go about doing this is like this. Basically what we're doing is we want to turn this thing here into something like this. Okay? So we want to get this expression here to look like this. And the way we do this is by completing the square. So here we go. The first step is just to get the terms with the x's on one side and get the integer on the other. And what we're going to do is we're going to complete the square of this. Okay, so let's just do that. If we complete the square, we get half. We get the coefficient of x, halve it, and square it. So half the coefficient of x. Let's just do that. That's minus 3. Square it. It's 9. Okay, so we've completed the square. Half the coefficient of x, square it. Now what we do is we add it to both sides. And the reason we add it to both sides is we want to make sure the equation is balanced. Okay. Now, if we look what we got here on this side, we've actually got a perfect square. Okay. So we've completed the square. So now this is the same thing as this. Okay. Square of the first, twice their product, square of the second. Okay. So getting half the coefficient of x, squaring it and adding it to both sides results in a perfect square. Now if we look at this side, I've got minus 3 plus 9 is 6. Now it's just a routine solve where I take the square root of both sides, so x minus 3 equals plus or minus square root of 6, so x equals 3 plus or minus square root of 6. Okay, let's try the next one. You'll notice this one here says correct to 3 significant figures. So because it says that, I'm going to get my calculator ready, because I know I'm going to need my calculator for this. Okay, so here we go. Y squared plus 2y, perennials on one side, constant on the other. Now let's have a look. Half the coefficient of y, half of 2 is 1, square it, that's 1. Y squared plus 2y plus 1 equals 7 plus 1. So I'll just say that again. Get half the coefficient of y, square it, add it to both sides. So 2, halve it, 1, square it, 1, add it to both sides. Okay. So what this is here, this is the perfect square. Let's just check. Square of the first, square of the second, twice their product. Y times 1 is y times 2, twice their product. No worries. Okay, so now we just square root both sides. Okay, so y equals minus 1 plus or minus root 8. Now, correct to 3 significant figures. Now there's 2 solutions here, so here we go. So y equals, now I've got minus, now just make sure when you're doing this you use the right minus sign. Minus 1 plus root 8 equals Now, three significant figures, 1.82, so that's 1.83, or minus 1 minus root 8 equals three significant figures, 1, 2, 3, minus 3.83. And I always like to say what I've done here. Thanks, guys.